Working Group 2, what we really deal with is impacts, adaptation, and vulnerability. And there are impacts of adaptation, but what we really want to figure out is what's the balance between the impacts of adaptation, of mitigation, and of not doing anything, and how those are conditioned by vulnerability and exposure. You know, Thomas started out by thanking all the people who contributed to the Ipcc, and of course the lead authors and review editors are incredibly important in setting the tempo and the contents. But there are two things for me that make the Ipcc process unique and uniquely valuable, and I want to just spend a second talking about those. The first is that Ipcc represents a unique partnership between the world's governments and the scientific community. As far as I'm aware, there hasn't been anything in history similar to this, and there certainly isn't anything for any other discipline in science, although we see an increasing body of evidence for a profound need for some kind of a systematic way to assess the science on policy-relevant topics. A second really key feature of the Ipcc is that the nature of the rules assures that Ipcc documents are pretty much documents of the entire community. Whether or not you were a lead author or a review editor, almost everybody has contributed by writing papers, reviewing Ipcc chapters, and building the body of information that gets assessed in the process. Now that also is incredibly valuable. We don't have anything else in the scientific community that provides whole community products, and it's why speaking as an Ipcc representative is so much different than speaking as an individual scientist with a particular set of skills and backgrounds. Oh, very sensitive button. We've already had a little bit of conversation about the motivations for thinking about climate change as a challenge in managing risk. It's one of the really important features of the Working Group 2 report. I want to talk about 5 motivations for understanding climate change as a challenge in managing risks. Each of them contributes to making the problem not only understandable, but also actionable. The first is that thinking of climate change as a challenge in managing risk connects responses to current climate variability, with which we're not prepared to deal already, with climate changes in the future. It establishes a continuum, not only of impacts, but a continuum of response options. A second motivation for thinking about climate change as a challenge in managing risk is that we've already talked about this morning how many of the consequences of climate change that lead to damages occur in extremes, almost independent of whether climate change is specifically altering the extremes or resetting the baseline such that extremes occur with a different probability or intensity. It's still the case that damages tend to occur in the extremes. You can think of extremes as the sharp end of the climate stick. It's where things break. A third motivation for thinking about climate change as a challenge in managing risks is it makes it really clear that we need to look at the full range of possible outcomes. There's already been good discussion this morning about the challenges of thinking about central tendencies, 5 to 95% probability ranges. But if we want to be effective in dealing with climate change, we need to be as sensitive to tail risks, the low probability but high consequence outcomes, as we are to the most likely outcomes. And how do we set up decision-making, decision support, science understanding framework that lets us do that effectively? And I think it's clear that there's a long way to go before we're where we need to be in terms of looking at the full range of possible outcomes with a balanced set of tools. Fourth motivation for thinking of climate change challenge and managing risk is that we already have a wide range of sophisticated tools for doing risk management. Those tools are relevant to solving the problem. They're tools at the level of the family, they're tools at the level of the firm, they're tools at the level of governments and international organizations. They take different forms at different levels. You know, at the scale of a family decision, risk management might be how much attention in a car purchase do you put into anti-lock brakes or a certain number of airbags. And at the level of a nation, it might be more about how do you think about investments in national defense, or how do you think about the longevity of infrastructure. But in all those cases, we're already utilizing sophisticated tools for managing risks, and those are all relevant to solving the climate problem. A fifth motivation for thinking about climate change as a challenge in managing risks is that we now understand climate change to not be a kind of an independent actor on the global stage, but really more of a threat multiplier. We face existing problems with land use change, with impacts on water supply, other kinds of impacts on biological diversity, social unrest as a consequence of economic, social, cultural policies. And in all these cases, the likely role of climate change is not to be some totally independent thing, but to make the understanding and solution of other problems different. In many cases more complicated, but in a few cases potentially similar. It's also really important to understand that the risk from climate change doesn't come from climate alone. It comes from the overlap between, as you can see here, the hazards, the triggers that come from climate change, and vulnerability and exposure. And it's only from the overlap between those three that risk of impacts really emerges. I like this figure, which was first used in the Special Report on Extremes, partly because it illustrates the centrality of climate change problem and managing risk, but also because it positions issues with the physical climate system, both through natural variability and anthropogenic change, and the social and economic processes in very appropriate ways, showing that with social and economic processes, we have the opportunity to modulate not only the amount of climate change that occurs through mitigation of emissions, but also through modulating vulnerability exposure through economic development, decisions about development. And finally, it highlights what I think is a really important feature of Article 2 of the UN Framework Convention, and it's important not only in the sense of Article 2, but in the broader sense of highlighting that our goal in managing climate change is really to deal with the climate problem in such a way that sustainable development can continue to occur. And that means not only to make sure that there aren't unacceptable climate damages to sustainable development, but also to assure that there aren't such great investments in either adaptation or mitigation that we pull resources away from other legitimate aspects of social and economic development. So it really highlights the kind of iterative process that's going to be required in order to find the pathway through what we can think of as the integrated development climate challenge. Oops, wrong button. They told me that was that this one was backwards. Maybe it's because no, I won't say that. I want to talk about a few of the findings before going to some thoughts about where we're likely to go in the future. One of the things that's different in AR5 than previous assessments is that detection and attribution of observed impacts has now reached a level of sophistication such that we can now identify and attribute particular kinds of impacts that have already occurred to climate change, and the observed impacts are already widespread and they're consequential. All continents, all latitudes, a wide range of sectors, and that crosses physical systems, hydrological, cryological systems, biological systems, phenological events, things like forest fires, changes in marine ecosystems, especially range shifts, and also lots of observed impacts on human systems, especially on food production and livelihoods, health, security. We tried in the Working Group 2 report a lot of different tools for making the information more accessible. One of the things that seems to me is when you present a temperature map, you have a vibrant detail there in every pixel. What's the temperature? And the challenge we face in Working Group 2 was that every pixel has the potential for thousands of different impacts and thousands of different adaptation options. And it's really difficult to paint the picture of that without having this cacophony of different information. Throughout the Working Group 2 report, we tried a bunch of ways to distill down the information into sort of understandable packages. But I think one of the big challenges we face, and I think there's a core challenge for the Ipcc, is that the scientific method is really based on inference and in establishing general principles, but communication is based on narrative, on telling stories that connect to people's personal experiences. And there's a fundamental disjunction there that we've never really exactly figured out how to deal with. Here's an example of the kinds of impacts that can now be attributed with quantifiable level of confidence, and thanks to Andy Challinor and the Chapter 7 team on food security for this one. And it shows historical impacts of climate changes that have already occurred on yield trends in 4 of the world's major food crops, wheat, soy, rice, and maize. And what you can see is that at least for wheat and maize, there have been measurable impacts already. One of the things that's interesting about these impacts is that they're impacts on a moving baseline. Yields have been increasing historically, but those yield increases have slowed as a result of the climate changes that have already occurred. A lot of emphasis in the Working Group 2 report is on vulnerability, and there's you can think of it as a classic vulnerability syndrome that's connected with poverty, limited access to resources, poor governance, poor health, issues related to gender, race. But one of the things that's really striking when you look around the world at different kinds of vulnerability is that it's not the case that vulnerability is located just in these highly vulnerable communities. In fact, if you look, well, I wasn't in the UK for the floods of this past winter, but I think there's lots of examples of vulnerability in the UK, and certainly Hurricane Sandy in the US in late 2011 exposed a tremendous amount of vulnerability connected to just a lack of consciousness of the scale of impacts that could occur, even with the climate events that we face now, independent of what mix those are of climate changes and natural variability. One of the core agendas in Working Group 2 is characterizing adaptation options, and one of the big differences between the current assessment and earlier ones is that there's now a growing body of explicit climate-related adaptation options that can be studied and evaluated. And they range from these engineering-heavy options like this flood barrier in the Netherlands to community-based adaptation like this mangrove planting activity. And so we're beginning to put together the pieces of a science of understanding adaptation, understanding the costs, understanding the differences between incremental adaptation, transformative adaptation, and what are the requirements for effective planning and adaptation. And you can populate the map with lots of different kinds of examples of adaptations that have already occurred, and we're at the early stages of doing the adaptations that are explicitly related to climate, and at the early stages of evaluating them, but we're really beginning to build the body of science on which further assessments can move forward. One of the things that we would ideally like to be able to do in an Ipcc setting is read out some kind of an accurate projection of a future temperature at a certain time, and then an accurate assessment of the impacts that are attendant on any given level of temperature increase at any level at any given location. And one of the frustrating things about where we are in the impacts world is that there are very, very few kinds of impacts for which we can read out progressive standard of impacts as a function of temperature. Basically, what we can say is that there are lots of cases where there's clear evidence for impacts that increase in severity and pervasiveness and in irreversibility as the amount of warming increases. But it's very difficult to read out specific impacts at specific temperatures. The consequence of this is really important in shifting how you set up your risk management problem, but it means that the deterministic paradigm of how you would solve the problem isn't going to be effective, at least until we have a lot more evidence from the impact sector. And my guess is it's probably not even going to be that relevant then, because so many of the impacts are so intricately connected with the vulnerability and exposure issues that are very difficult to project. So that sets up a narrative that's sort of the foundation for the AR5 Working Group 2 assessment. And the narrative basically has 4 parts. We can characterize the risks that we face today. In this plot, they're characterized by the trajectory of historical temperatures over the 20th century until the present. And we can think about temperatures over the next few decades, as shown by the arrow here. There's a period where even with ambitious investments in mitigation, there isn't a big difference between the climate trajectories for the most ambitious mitigation scenario, RCP 2.6, and one of continued high emissions, RCP 8.5. So you can think of this as an era in which the impacts that we're going to experience are already baked into the system, and any things that we have as response options are going to be response options via adaptation, not via preventing the impacts. But it's also really clear that impacts that climate changes late in the century do depend on mitigation decisions that are made in the short term. You can think of this as the era of climate options, where what we do now determines whether we're on the essentially 4C RCP 8.5 trajectory or the 2C RCP 2.6 trajectory. And so that sets up the contrast between the two worlds that you can see in the bottom plots, essentially a 2C world and a 4C world. Those are essentially the four elements of the challenge space, the problem space we can think about with the level of impacts and adaptation information that's available now. There's challenges for the present, challenges for the near term of mostly committed climate changes, and then options at the end of the century for a world with more or less 2C of warming, or a small amount of warming, ambitious investments in mitigation, and non-ambitious investments in mitigation. And you can think about it setting up as this, that we would like to be able to characterize the risk level for each of those four conditions. And here's just an example of what the risk might look like. And one of the things that we introduced in AR5 was an approach to doing expert judgment-based evaluation of risk for a variety of sectors and regions at these four condition states. And then we also said, well, and what's the potential for adaptation to reduce those risks based on what we know about the adaptation options? In very few cases are these risks determined with a purely quantitative model-based approach, because we simply don't have enough information to do that. But we're essentially challenging the author teams and by the structure of the Ipcc, the broader scientific community, to say, okay, what's the likely outcome in terms of a risk profile at each of these conditions, using the combination of all the literature that's available and expert judgment. And then how much could you back that risk off as a consequence of high investments in adaptation? So this tells you what's the adaptation deficit that we face currently. That's the difference between the present condition with high adaptation and current adaptation. You can say, what are the impacts that we need to do adaptation in response to in the near term? You can say, what are the benefits of investment in mitigation? That's the difference between the impact level in the 4C and the 2C world. And what are the potentials for adaptation? That's the consequence on each of the bars, going from the end of the bar to where it transitions from gray to blue. So essentially this provides, to the extent it's available, an expert judgment of essentially the key aspects of the climate challenge. And we asked all of the chapter teams to undertake this expert assessment. And here's a characterization of some of the topics that were addressed in the regional chapters. And what you can see is they address things like flood, water availability, heat stress, drought, coral reefs, damage to crops, infectious diseases, wildfire, the rate of change, damage to fisheries and coral reefs, damages to livelihoods and coasts. Overall, these risk tables present a comprehensive picture of what we'd like to know about climate change, its impacts, and the options for dealing with it through mitigation and adaptation, but at an expert judgment level based on information that's much more limited and incomplete than we would ultimately like it to be. The other thing that we really tried to do in the Working Group 2 setting is boil the full set of possible impacts into a manageable number of reasons for concern that, as much as anything, indicate why it's not appropriate to think about solving the climate problem with a simple cost-benefit analysis, a linear monetized cost-benefit analysis. Because the fact of the matter is that many of the things that we care most about in the Earth system are very difficult to express in monetary terms, or where different stakeholders from different cultures, different ethical perspectives would bring very different values to the metrics. Based on pioneering work by Steve Schneider and others in the third assessment report, the Working Group 2 came up with 5 categories that allow us to think about the different possible kinds of impacts of climate change and how they might be combined. The leftmost bar is unique and threatened systems, rare and endangered species, unique archaeological or historical sites, lots and lots of systems where it's hard to calculate the value because they're essentially irreplaceable and one-off. We already talked about the challenges of extremes, and the challenge of pricing extremes is even greater than the challenge of projecting them. The middle bar is a really important one. One of the essential features of climate in the 21st century is the distribution of impacts isn't fair in some sense. Many of the individuals, many of the ecosystems that will experience the most severe impacts didn't contribute to the problem and have the fewest resources for doing solutions. Different stakeholders will bring very different values to this question of the essentially unfairness of the climate challenge. The fourth bar is global aggregate impacts. So those are the things that we often can monetize, things like total losses of economic consumption, but it could also be measured in total food production, total biodiversity, total food production. I think I said food production twice, sorry. And then the fifth bar is large-scale singular events. That's things like the collapse of a continental ice sheet. And at what point are we committed to major irreversible changes in the way the Earth system works? These 5 reasons for concern you can think about as setting the texture for answering the question of what's dangerous anthropogenic interference with the climate system. They don't answer it with a single sentence, but they provide essentially a series of starting points for a discussion that can bring different stakeholders to equally legitimate perspectives on what the answer is. So I'm going to end with what I consider to be a core finding of the Working Group 2 report, although it's a little bit hard to explain why it's a core finding. And when we look at options for adaptation and look at options for mitigation, the available sciences are really a wide range of co-benefits out there to be harvested. There has been a narrative in the climate change dialogue that climate change is about paying to change things, is about giving up on future opportunities. But if you look at the data, you see a pattern that's very different, that dealing with climate change can be a robust and vibrant way to enhance sustainable development, to enhance economic security, to enhance cultural security. And the real challenge is how to set up a smart policy environment that lets you capitalize on those things. So in order to do that, in Working Group 2, we think about what I had characterized as the problem space earlier as really representing also a map of the solution space. And each of the elements that potentially represents a problem also has a wide variety of solution approaches that are attendant on it. And they really transform the challenge of managing risks in climate to a challenge of capitalizing on opportunities to be effective in dealing with climate. Some of those are in the mitigation sphere, but some are in the risk management sphere, some are in the adaptation sphere. Whoops. So I know how you go forward. I don't know how you go back in this thing. Which one? Okay. I could have figured that out. Okay, so I just want to say a few things in closing. The first is that there are really a wide range of benefits in thinking about climate change, challenge, and managing risk. But as we've already discussed, there are a number of aspects that are incompletely explored. There's essentially a narrative that hasn't been fully developed. It's also really clear when you look at the diversity and complexity of Working Group 2 issues that there are many senses in which we're dealing with a problem with deep uncertainty where the uncertainty is not going to be reduced rapidly in the future, even though there are tremendous prospects for learning more in the physical climate system, in the impact space, in the adaptation space. But we need to figure out ways to make decisions under deep uncertainty, taking advantage of the risk management tools that are already available, but also developing new tools for effective decision support. Part of the way to do this is thinking comprehensively about the map of a problem space and a solution space and how those interact with each other. But at least for me, if there was a single lesson I learned more clearly in reading the Working Group 2 report than any other, it's that the best way to solve the climate problem is not to plop down 2,000 pages of report on the desk of a policymaker. The key to an effective path forward is opening a dialogue where the scientists get to hear from the stakeholders about what the issues are, come back with proposals about providing the information, and have an iterative dialogue about moving towards solutions, not a one-way flow of information where scientists say, we know, you respond. And I think that's the lesson that I took away from my work with the Working Group 2 report. I can say it's the lesson, but I can't say that we really know how to move from the production of the massive, rich, wonderfully interesting reports to the kind of a dialogue that's going to be necessary to move us to real solutions.